Hello everyone, welcome back. Here is vanAmsen, and today we are going to solve an exciting problem: number of ways to reorder array to get same BST. So it's hard level problem. So be prepared for some intense coding and mathematics. So now let's dive right in. All right, so the problem is quite long, but I will break it down for you. So we will are given an array of nums that represent permutation of integers from 1 to n. And we have to construct a binary search tree, BST, and then find the number of different ways to reorder nums so that the BST remains the same. So the problem provides a few examples which are really helpful in understanding it. And the key point is the answer can be very large. So we need to return it modulo 10 to the power of 9 plus 7. So given example number 1, nums of 2, 1, 3, output should be 1, and this is because we can create permutation of 2, 3, 1, so from nums of 2, 1, 3, and we have additional 1 permutation to receive same binary search tree as represented in example 1. So let's decode approach. We will use a recursion and helper function DFS inside of num of ways function. So first element of nums will always correspond to the root node of BST, and we will construct two subsequences, left node and right nodes, and then construct two subtrees using these sequences. So as long as the relative position of the elements within each sequence remain unchanged, rearranging their position in the nums does not affect the construction of particular subtrees. So it's very important. And so our recursive function will be just DFS and will be equal to DFS of left node multiplied by DFS of right node. However, there are some permutations that doesn't change the relative order of node in the left and right node and still result in the same BST. So this is where we introduce a coefficient P that represent the number of permutations represented the relative order of the nodes. So let's move to the code and I will explain it right away. So modulo 10 plus 7, we will use this for taking mod of result to keep it in limit, and def DFS of num of list, so it will output int our recursive function. So now m will be length of nums and size of the current list, and base case will be just if m less than 3, we return 1. If less than 3 elements, return 1. Only way to permute 3. Generate left and right node, base root node, first element of nums. So left nodes will be just a for a in nums if a less than nums at position of 0. Right nodes will be a for a in nums if a less greater nums. So recursive formula DFS left of right node times combination and left node. So return DFS of left node times DFS of right node times combination m minus 1 of left node length. So modulo 7 because it might be big, and return the fs of nums minus 1 modulo, and we subtract 1 to exclude original array or original permutation. So let's run it and see if it's working. So yep, I run. So it's working. So for provided test cases. So this is a Python class with a method num of ways, which where our logic lives, and in this function nums is the list of integer from our problem statement, and we keep the value of mod 10 to the power of 9 plus 7 as the problem wants us to return a modulo value. And the DFS function here is the function with the core of our logic, and it returns the number of valid permutations. So for m size of nums, if it's less than 3, then it simply returns 1, as there is only one possible permutation for 3 elements. So otherwise, it selects the first element of nums as the root node, and it partitions the remaining elements starting from num 1, so we exclude the first element, into two subsequences, left nodes and right nodes. So left are less than first element, and right are greater than first element. So then we call recursively DFS left node times DFS right node, and times combination with respect to m minus 1 and left node length. So this problem involves a construction of binary search tree by inserting the elements of a given array in the proper order, and we need to find the number of different ways to reorder the array so that BST format is identical to the original BST. So let's understand the problem and the solution we have implemented. So key points to note here are: the first element of our array is always correspond to the root of the node. All elements less than the root will belong to the left subtree, and all elements greater than root will belong to the right subtree. And as long as the relative order of elements within the left subtree and the right subtree remain unchanged, reordering the position in the array does not affect BST at all. So some permutation do not alter the relative order of nodes in the left and right subtree, thus resulting in the same BST. So this is very important, and this needs to be counted separately. So that's why we have a multiplication. So we are dealing with a recursive problem, and we divide our array into two parts, left node and right nodes, to solve this problem separately. And then to solve this problem, we will use a combination function using recursion and calculate the binomial coefficient. So this is binomial coefficient function, and in nums of way, we are given an array of nums, and we check the formed BST trees, and inside this function, we define another function, DFS, and check the number of permutation we have previously done. So we have two base cases: when the array is empty and when it contains only one or two elements. So in these cases, there is only one possible permutation. So whether it's empty, whether it's 1, or whether it's 2, so the function should return 1. So basically, if less than 3 elements. Otherwise, we split array, and we can split it with left nodes and right nodes. And basically, when we each partition of recursion will split to this point where we have only 0, 1, or 2 elements, we will return final 1. So the total number of valid permutation of nums is the product of the number of all valid permutation of left node and right node multiplied by binomial coefficient of the size of nums and left node. And this binomial coefficient represents the number of ways we can choose the element of the left node from nums. So this is just a function for binomial coefficient using to obtain the permutation. So finally, we subtract 1 from our final result, and this is because we need to account for permutation of original array itself, because it isn't counted, because we are asked how many other permutation we can obtain. And yeah, so this is a whole explanation. So finally, we return just DFS of original nums, and we enter into state of recursion. And in this term, our time complexity will be about O(n) square, because we are performing O(n) operation for each of the n elements in our original array, and the space complexity will be also O(n) square, because we are creating two arrays, left node and right nodes, for each of the n recursive calls. So let's run it for unseen test cases. So it's the biggest part. Hopefully it worked and no timeout. Yeah, it's working. We have successfully completed day 18th of daily challenges, and implementation beat 42% and 30% with respect to memory. So everything is good. I hope you liked this video. If you like, please make thumbs up and subscribe for more coding challenges, tutorials. And if you have any question, please leave the comment down below. And as usual, it's good to understand the problem and keep practicing to improve your skills. And happy coding. See you next time.